Good morning, everyone. How are you doing? Hope everything is going great with you. Okay, so let's continue talking about the limitations of file-based approach. As a recap, we have discussed in the previous lecture, we have discussed the file-based approach, and we said it works properly when the data or the amount of data is small only, but it breaks down if it is if there is a cross-referencing, like the data related to multiple resources or multiple references or categories, okay? And we gave some examples about it. Now, what are the limitations of file-based? We mentioned some limitations. Let's continue. In the file-based, we said there are some terms to be considered, like the file is the main part of the file-based system, and it includes a number of records, and the records also contains number of fields with some characteristics about each object. And then we gave example about the file-based, and we said every application program is or has its own or deals or control or manage its own files, and it is stored in separate folders, which is not linked to other application programs. So this will lead to some problems and limitations, like we said separation and isolation of data. This is number one. So every application program will deal with its own data. Okay, it will be isolated from other programs, and in case one application program needs to get access to another application program data, there will be a problem because there is no link between them. It's separated. So data might be duplicated. This will lead to the next one, which is duplication of data, because there is no ability to access other application program data. The other department might duplicate some sort of data. So same data will be repeated and duplicated, even if it has different formats, which will cost the corporation or the organization, and it will be a waste of money and efforts and loss of integrity as well. A number, and we said we gave example here. We said if an employee change, or if the address of an employee or member of staff changes his address, it will be changed, for example, in one department, in the personal department, but it will not be reflected in other departments, like for example payroll. So the pay slip will be sent to a wrong address. So this is one example. Another limitation is data dependence. This means that the file structure is defined in the application code. So in case the department or the department or any member of staff needs to change the file structure, there must be an entire change in the application code. So this will be a bit long procedure. Like for example, they will open an original file, they will create a temporary file which has the new structure. Okay, then there will be reading from the original file, converting it to conform the new structure, and it will be written to the temporary file. They will repeat it for all records, all right? Then they will delete the original file and rename the temporary file as the original, and it will be, so all programs will be modified. All programs related to that file will be modified just to conform the new structure. So this is the meaning of data dependence. The file structure is embedded or defined within the application code. So in case we need to change the file structure, it must be changed within the application code. And this will cause problems as well, and more pressure on the data processing stuff. There is another limitation, which is incompatible file format. As we said, some files might be repeated and redundant, and it comes with different file formats. So it means that not all application programs will be able to access these file formats. So there will be compatible file formats for specific application programs because it's written in different languages. So it will be very hard to get access to incompatible file formats from different application programs. And this is the last limitation here, fixed queries. We said the file-based is just, for example, just using some sort of fixed queries or planned queries. Queries means like requests. Like, for example, when an application needs to print out a report, okay, or need to perform some calculations, like, for example, total, average, maximum, minimum, all right? So it will be, for the file base, it will be fixed. There will be no plan for different queries, all right, different requests. So in case the application program will need, or for example, one member of staff will need unplanned query, or will need more functions or particular function, there will be a new equipment must be performed using a new program, or it will need a new program. All right, so it's fixed. There will be no plans for any additional queries. So it will put pressure on the DP staff, these limitations. So everything will be handled by the DP staff, the data processing staff, and some other limitations related to there will be no provision for security and integrity. There is no clear mechanism to secure all these application programs within the file-based approach, or even the data consistency or integrity. So it will be like duplication of data, data dependence, so there will be loss of consistency and integrity. Also, there is no plan for recovery. So if there will be an error in the system, so any failure in the hardware or software, it will not be fixed easily, all right, because there is no recovery mechanism. Access to the file was restricted to one user at a time. So just one user at a time can be accessed. So one user, the application program will be or can be accessed by only one user at a time. So these are also more limitations, which puts more pressure on the organization or the DP staff. So because of all these limitations, there was an essential need to have the database approach which will fix all these limitations and problems. And all limitations will be resolved by having more centralized system. So as you know that the file base is not centralized, right? Because each department or each application program will deal with its own file and it will be stored in separate folders. But in case we are using a database approach, it's more centralized, more integrated, and more linked together. So there will be all these limitational problems that will be resolved by the database system. Can you remember the terms of database? Database system includes how many parts are there in the database approach? Yes, anyone can tell? Yeah, okay. Anyone? Database approach, database system includes number of parts. There are parts, starting with the database itself, right? Database. And then, yes, exactly, Betul, thank you. Database management system. So there is a database. Yes, correct, excellent. So database application and the user. So we have the database itself. It's the collection. Just to just to repeat this kind of information. I want to refresh your memory. Database is a collection of logically related data. And there is the database management system, which control access and manage access to the database itself. And it will be interacting with the database application, which provides an interface to the user, right? So these are parts. If we are talking about database approach, we mean that the definition of data is embedded in the application program. And it's not separately stored or independently. So it's embedded in the application program. The data definition. All right. This is if we talk about the database approach. Sorry, I didn't mean that the database approach. The file-based approach, the data definition is embedded in the application. So in case we need to change the file structure, we need to change the code, the program code. And also, if we want to access or control access to the data, all right, we cannot have this full control in the file base. But unlike the database approach, the data definition will be it's not separate. It will be not like what we can see in the file approach. So let's discuss this, the main reason of having the database. As we mentioned that the database, it's a shared collection of logically related data. This is the definition of the database, right? This is the database. Also, not only related data, the description of data is or will be defined as well. The description of data, and we will talk about it later. So it's designed to meet the information. So to meet the information needs in the organization. All right. So large amount of data will be handled easily by using the database system. And instead of having duplicated data or disconnected files, there will be more integrated system, okay, with minimum amount of duplication. So this is the main idea of having, or main reason of having a database system. So that the system will be centralized, integrated, and no redundant data. Okay, because you know here there are two main reasons that puts this essential need to have a database approach. Because the file-based or the data definition is embedded and stored separately and store within within the file-based, within the application code. So this is something very important. If the data definition is embedded with the application program or with the program code, this means that any change, any further change will require very long procedures or steps that must be performed in order to fix or resolve this. Okay, or modify it. So this is one reason. So data definition is embedded in the application code or application program. But in the file base, on the other hand, in a file base, it will be stored separately and independently. So if we need to, for example, change or modify the file structure or the data definition, it will be changed easily without affecting the program code. Got the point? This is very important to be understood. So number one, data definition, since it's in the file approach, since it's embedded within the application program, which means the file structure is defined also in the program code. So it depends on the program code in the file base. This will lead to some problems in case we need to modify something in the file structure. Unlike the database approach, which provides a data definition stored separately and independently from the program code, which means that in the database, we can change, we can modify, right? We can update the file structure or data definition very easily without affecting the program code or the application program. This is one reason, this is number one, why we need to have a database approach. Okay, or why we had why there is an essential need to have a database approach, because of this reason. Number one, data definition and the file base is embedded. This will waste time, waste effort, waste money if we want to change something in the file base. So that's why we have it much easier. The process will be much smoother and easier in the database approach. So this is in the file base, okay? Reason number two, in the file base, there is no control over access and manipulation of data. Okay? So if we want to have full access and control over the data in the application program, we need to have more centralized. Why there is no control? Because it's not centralized. It's not integrated system in the file base. All right. So these are two main reasons that have, for example, or encourage having the database approach. The result, we have the database management system. All right. So as we said, the database is a collection of logically related data. It's not only the data, the description of data as well. Okay, and it's more centralized system and integrated with minimum amount of redundant data. Now, what are the other terms that related to database approach? So the database approach, DB, it's not DB means the database. Okay, it's not owned by one department. It's a shared corporate resource. Okay, so it becomes, in the database approach, it becomes a shared corporate resource. It holds the not only the operational data, as we said, it holds also the description of this data. And the description of the data can be stored in something we call system catalog. What is this? The system catalog? We can also, alternatively, we can call it metadata, data dictionary. Okay, all these are alternate terms of system catalog. So metadata, data dictionary, data about data, or system catalog provides description of data. Okay, so to enable the data independence. What is the meaning of description of data? For example, when we talk about student entity, okay, if we are having a University of Bahrain database, this is an example. All right, so the database system will be owned by the University of Bahrain as a whole corporation, not owned by only one department, right? So it will be public, like public resource or corporate resource shared by many departments. So what kind of data, okay, are held by the database? Data plus the description of data. What is the data? Data are like, for example, students, everything about the student information, student timetables, student registered courses, student transcripts, okay? So all these kinds of data stored in the database. What about the description of this data? What is the system catalog? Which data are provided? Which kind of data? There are so many kinds, so many types of data are provided as description of this data. So for example, student, there will be ID number, right? In the system catalog, the ID number will be described as a number. So like, for example, integer, long integer, you have an idea that the number will be different types, or how many number of characters for the ID, for example. All right, so this is a description of data. Get the point? System catalog or metadata, data dictionary, or data about data will provide some descriptions about data. All right, so like ID characters, for example, it will accept 8 to 9 characters. It will be integer or long integer. It will be, for example, starting with 2000. For every academic year, we'll start with 2000, the year. We'll start with the year, okay? And so on. So these are all a description about this specific piece of data. For example, the name. Okay, the name will be, for example, character, and it will accept 200 characters. So there will be number of characters allowed for this field, for example. And it will be like in caps lock or capital letter. For example, this is all about, or it will describe the data itself, whether it's a number or character, and how many characters will be accepted. For example, if there is a field to be described for the total, okay, there will be a maximum and minimum, and so on. So all these are description of data, will be stored along with the data itself. Now, as you know, in the file base, the data definition is stored dependently on the application or program code. This is very important to be understood. Okay, this is the data definition in the database. On the other hand, it is stored separately from the application programs. Okay, which means that we can update it easily without affecting the application program. So data definition is separated from, this is very important about the database. Because of that, because the definition of data is separated from the application program, so end users only can see the external definition of data, and they are not aware of the internal definition. Like, for example, there are so many functions, so many objects, so many characteristics for every object in the database. For example, you as a University of Bahrain student, are you aware of everything about the data in the system, internal definition of the data, or just the interface and external definition of the data? As a University of Bahrain student, anyone can, for example, know every field specifically, what kind of data it will be accepted for every field in the SIS system, or just the view or interface? You know that, right? You can see just the external. Exactly, Yusuf. So you are just having an external look to the database. That's the meaning. That's exactly the meaning of the data definition is separated. Exactly, Batul. Thank you so much. View. See, this term is very important. So there will be a view, another view for different users. For example, my view as a faculty member will be different from students' view, right? So it will be not the same. So there will be in the database approach, you can see that there will be many views depending on the user requirements. All right? Okay, so what is the main advantage of having the data definition separated from the application program? That is the data abstraction. What is the meaning what is the meaning of the data abstraction? It means that the internal definition can be changed without affecting the user or the interface or the views. Okay? Are you aware, for example, of changing the number of characters accepted in the courses, for example, courses field? You are not aware, right? Because anyone will change something internally, it will not be reflected, or sorry, it will not be it will not be shown or displayed for the external view. All right, so this is the meaning of the data abstraction. Any change in the internal definition will not be affecting the user or the external definition. All right, so this is something important, okay? Data abstraction means the process of changing the internal data definition of any object in the database, okay, without affecting the users or the view of the users about the same object. Okay. It's all because of what? One thing, that the data definition is stored separately, independently from the application code. That's the main reason. Okay, if a new data structures are added, this is an example. If a new data structures are added, or existing structures are modified, all right? The application programs are unaffected. So this is just for you, for more clarifications. So they don't directly depend upon what has been modified. So in case we are adding a new file, sorry, not file, this is a mistake, okay? If you are adding a new field, the applications are unaffected. A new field means for the student relation or student table, I'm going to add, let's say, the address, for example. We decide to add each student address, okay? So I'm going to add it, but at the same time, the application will not be affected, okay? But if I remove the field and the application is using that field, in case the application is using the field which I need to remove, in this case, it will be affected. Got the point? If the application has a direct, for example, link, or it involves with some particular action with the data or the interface, the application is using that field, the particular field, and that field will be modified or removed from the database. In this case only, it will be affected. Otherwise, it will not. See, something to be modified is one thing, but something to be removed from the application that displays that object, this is another thing. Like, imagine that your transcript has field displaying, let's say, what shall I add? For example, it's displays the previous courses, okay, grades. For example, the previous, if you are repeating a course, it will be displayed in your transcript, okay? Imagine that we decided if the student repeated it and he got an improved grade, okay? That one, the previous one, will be removed from the transcript. If it is removed, okay, so then the application view will be affected. Why? Because the student will no longer be able to see that previous grade. The new grade will be added. So the column of previous grade will be removed. That's just an example, okay? So anything to be removed and the application is using it, the application will be affected. Okay, what are the main elements? The main elements of the database system are three. Okay, three main elements. So as we say, the database is a collection of logically related data. What is the meaning of logically related data? Logically related data means that we have number of entities, and the entities will contain number of attributes, and there will be relationships between entities. So that's the meaning of logically related data. All right. So what is the meaning of entities? Entity. What is an entity? An entity is any distinct object. Like it can be a person, it can be a place, it can be a concept, event, thing, anything. Anything in the organization to be represented in the database. So this is the entity. Okay? Like in the University of Bahrain database, I ask you, I remember in the first lecture, can you give me examples about entities or relationships in the University of Bahrain database? Can you give me now examples? Can you remember? Let's assume that we have University of Bahrain database. What are the entities that must be represented in the database in the University of Bahrain? Yes, exactly, Batul. Departments. Qasim, yes. Students, okay? Student ID is another thing. Student ID is an attribute that describe the student information will be under student entity, okay? So entity is a whole, okay? The parts of the whole will be attributes. Got the point? So student entity, department entity, what else? Faculty members entity, right? Admin entity, registration entity, admission entity, any distinct object. Yes, staff, HR, for example, HR entity. It's like groups of, or let's say departments, no, colleges, for example, will have or will contain departments, and then there will be staff members and so on. So got it, right? Another example, if we have an organization, like a company. A company includes number of departments. What are the entities? What are the entities that will be there in the company? Commercial company, not the University of Bahrain. So there will be many, like employees, right? Employees, entity. What else? Managers. Okay, HR. I just need to make it clear for you that any group of information related to one particular entity within the corporation can be counted as a distinct object. Yes, exactly, Batul. Customers. Yes. حتى even in the University of Bahrain database, we can say courses, like courses entity, right? And we can say also sections within the courses, faculty members, doctors, شنو بعد purchasing or purchasing department, okay, accounts, for example. So anyway, every entity will represent a distinct object. It can be a person, it can be a place, it can be a concept, it can be anything within their organization. Okay, how about the attribute? The attribute means it's a property that describes some aspect of that object. Like, for example, if we have here, if I have, let me just draw this. If we have student entity, this is the student, right? This is entity, students. Okay? This is one entity. Yes, exactly, Qasim. It's representing some characteristics about that entity. Now, what are the attributes for students? What are the attributes for student? Anyone can tell? Yes, exactly. خلاص شيل ذي. ID, name, what else? Major, yes, exactly, you are right. So I have this entity, GPA, yes, that's correct. So you know now what is the meaning of attributes, right? It's some characteristics of that entity. Is it? Let me draw it this way. This is the student entity. And what comes inside this entity, as you said, there are attributes. So ID, name, major, and so on. Okay, there are so many attributes that can describe some aspect of students. All right, so these are just examples. So this is the entity. So what is this? This is the entity. This is the entity. And what comes inside? These are attributes. Okay, I'm gonna write here. So this is the entity. Entity. Now the attributes in which describes some aspects or which displays some characteristics of students. These are attributes. وين أكتبها? Okay, I will write it up there. These are attributes. Okay, now let's assume that we have another entity which is courses, okay? Another entity which is courses. Now, let me just write courses. Here, courses. Okay, شو ما يصير هلا مش أشيله. Courses. Okay, and we have here. What are the attributes of courses? Now this is another entity. Courses attributes. Anyone can tell? Okay, credit hours. Yes, name or course code la. First, sorry, course code, course title or name. Yes, credit hours, for example, credits and so on. So there are many attributes for the courses. Now, let's talk about what is the relationship. Let's talk about the relationship between these two entities. What is the association between students and courses? What is the relationship between students and courses? So this is the main point here. Logically related data. Related means they're is a relationship, or there are relationships between every object stored or represented in the database. All right. So what is the relationship here in this case? Where is the relationship here? We can draw it like, I will draw it in green color. See, this is the relationship. What is it? We can, for example, draw, where is, okay, anyway, I'm not going to be more specific here. There must be a small arrow here. So student, what is the relationship? Student what courses? Student what courses? What verb we can add here? Students what? What are you doing here in the University of Bahrain? What do you do with the courses? You register, you add, you do what? I mean, let's talk about, okay, learn, but let's talk about the registration, for example. So a student, what? Register courses, right? And there will be a small arrow here. I don't know if I can draw it here, like this. Okay. Yes, and the registration, exactly. So we have student. So here we have, let me draw it this way. See, this is a small arrow, indicating the direction of the relationship, okay? The direction of the relationship. So students register courses, right? Student register courses. So the relationship between student entity and the courses is register. Okay, register. So it's an association between these two entities. Got the point? This is the main structure of the data represented in the database. If you got it, you are in the safe side. Any question about this? يا جماعة فاهمين الموضوع؟ الداتابيس شلون يكون الداتا structure? Entities. Every entity includes or contains some attributes, and there are associations or relationship between entities. Yes, exactly. Okay. Now let's talk about the database management system. This is a software. We talked about it previously. We mentioned that it's a program or a software that controls, manage access to the database, right? Let's be more specific here. What is the thing that database management system can give the users, can enable the users? It can give them or enables users to define, to create, to maintain, and control access to the database system. So what's the point of having a database management system a program or software? Because it allows the user to define, to create, to maintain, and to control access to the database. So the user will be able to control, for example, access to change, to modify, to create tables, to create queries, to create reports. Okay, so many things can be done within. Yes, it can. The process over the database itself can be controlled and managed easily. Like, for example, who from you who have ever used Microsoft Office Access? أحد استخدم Microsoft Access? Let me just put it as an example here. Example. Yeah, this is the same. Microsoft Access. Microsoft Access will allow the user to create tables, right? To update the tables, to maintain the table, to control access to some specific amount of data. And also, yes, excellent, Qasim, you are able to hide a particular amount of data from other users. So this mechanism can be done only by using the database management system. All right, so you are able to do all these things by having piece of application. Now, in the database management system, there are two different definition languages. Two. Number one, DDL, which is data definition language, which allow the user to specify the data type, the structure, and the constraint of the data stored in the database. So this is number one. By having the data definition language, the DDL, in the database management system, users are able to, for example, to identify the data type of each field, to identify the structure of the data. Okay, so you can, by having the DDL, you can define or specify these things. You can define data type, you can identify the structure, the constraints means some restrictions that can be applied over the data. We will talk about it later. While you can use the other part of the data language or the database language, which is data manipulation language. Manipulation means you are able to manipulate, you are able to change, you are able to update. Okay, so in the part of data definition language, DDL will allow you to, or will allow the user to define the language, sorry, define the data type, the structure, and the constraints over the data. While the DML, the data manipulation language, will allow users to insert, to delete, to update, to retrieve from the database. All right. So since it's centralized, it provides general facility to the data, will be called query language. Okay, so DML will provide a facility to be used over the data like a query language. What is the query language? An example is SQL. SQL is structured query language. Okay, so the DML, the database management system like Oracle, like Access, like whatever you can use, contains two parts or has two parts to be defined. Okay, data definition language. Java is something else, Yusuf. SQL is a facility, okay, that can be inquired by the DML, which is embedded with the database management system. So it's a program, and there will be two languages in this program. One part of it's not a language, it's like, it's database. It's a partial language, not a language like used like C++ or Java or whatever, or PHP. No, it's like a facility within the language. All right. So DDL. No, you don't have. But at least you will have a better understanding about these tags. It's very simple and straightforward. Okay, Yusuf, so don't worry. SQL is very easy. There will be some sort of, and very short lines to retrieve data, inshallah. So don't worry. So by having a DDL, data definition language, within the database, you are able, or the user are able to specify the data type, which means what is this, what is this? This is a number or integer or a character. Is this, for example, a calculation or a comparable, for example, operation? Okay, it's a logical, or you know what I mean? So it's the data structure or data definition. While having DML facility represented by a query language like SQL, okay, we have DML to allow user to manipulate, to delete, to insert, to update, and these sort of things. Yes, Qasim? Yeah, for the database management system. If you are working within the database management system, you can do these two things by using DDL and DML. DDL for defining defining the data types and structure and constraints. DML for manipulation. It means inserting, updating, deleting, and so on. Inserting, updating, deleting by the query language, which is, for example, structure query language. Okay? All right, so we will stop here. Okay, so the time is up now. Let me just see the attendance. Okay, I'll just get it from the system, but I'm just I'm just making sure. Okay, so thank you so much for attending today. Hopefully by next time we will finish this chapter slide. And if you have any question, don't hesitate to ask, okay? Now you have a clear idea about the database system, right? File-based database system. So if you have any other question, just ask me next time, inshallah. Okay, you are welcome. Thank you so much. Have a good day. Bye-bye.